medical student at UNC, research scholar at Duke Heart Center. Today we're here to talk to you about using algorithms to optimize the donation after circulatory death process, otherwise known as DCD. I'm joined with my colleagues, Talha, who was a consultant in biotech, decided he wanted to be a surgeon, so now he's studying medicine with me at UNC, and Isam, who is a computer engineer specialized in artificial intelligence in medicine. Isam develops devices with the support of IBM and Intel, but they are not affiliated with this project and we don't represent their views. So, kind of giving you the story of how this started, we recently published a study last month about where we established the clinical validation standard for artificial intelligence in medicine. And we used it to evaluate clinical validation in FDA authorized medical AI devices, all the ones out to market. When we came to the conclusion of this study, we said, okay, now we have a way to measure how AI in medicine performs, a way to measure its safety and its effectiveness. But we asked ourselves the question, what's next? What is the most impactful use case for this new artificial intelligence and algorithmic technology? And so Dr. Merlot and Dr. Haithcock at UNC helped answer this question. They basically started thinking, okay, now that we have these organ care systems that expand our potential organ donor pool by preserving organs and allowing us to donate organs after circulatory death, they asked, how well is this being utilized at our institution? And we pulled together our team, Isam and Talha, and our research partner, Ihsan Yüksel, to really answer the question, how can we use the technology that we now have at our disposal to optimize this process? And we really feel like we're in the right space for this now, because when you think about it, particularly in transplantation, there are not many uses of AI and algorithm in the field, and a single additional organ donor is multiple lives saved. And of course, it has implications for transplant procedure volume, the things that heart surgeons care about. So what we did is a retrospective analysis of all deaths at UNC from 2020 to 2022. And we analyzed over 2,000 patients. Dr. Merlot came up with the exclusion criteria to really narrow down who would have been a DCD organ donor now that we have these organ perfusion systems. And so you can see that the list is long. We were very strict with the criteria, and shockingly, we found that 93 to 94% of people who could have donated DCD heart and lung were not approached by the organ procurement organizations, known as the OPOs. The OPOs didn't go to speak with the families, and then if we're, having integrity and then showing like the smaller numbers, you could also frame it only 6 to 7% of potential DCD organ donors were approached for donation. So we're missing a huge population here, and if we can optimize this process with the technology that we now have at our disposal, we could potentially increase DCD organ donation by 15 times at our institution. And so, this complicated map here is really just showing, how we narrowed it down to 247 qualified DCD heart and 262 qualified DCD lung donors that were missed with current workflows at the institutions. We did a health system analysis to try and really narrow down what are the breakdowns in the system as it is. And we basically followed patients from admission to ICU all the way to having their organs transplanted at 3 hospitals, 2 different medical systems. And really what we found was the process as it is really has breakdowns because, first of all, in the process for identifying a potential organ donor is done manually. You're relying on busy ICU staff to pick up the phone and call the OPOs to come and coordinate the transplant process. And so we find that we have a lack of utilization of DCD likely because not enough calls are being made to the OPOs. So there's some reasons for this. First of all, human error. The staff forget to make the calls. The OPO cannot approach the families until the decision to withdraw life support is already made. And the reps have to keep checking in every few hours to see if they can catch when that decision is made so they can coordinate the transplant. And then if you have too much time passing, that's too much ischemic time, the potential organ donors the organs get wasted. And so, sometimes some of the staff won't even call the OPO because they don't want to deal with the reps. And so you literally have a lost organ donation because of that. So what we did is we tried to figure it out. We designed an algorithm that would automate this process. Would automate the process of identifying when a patient is approaching imminent death with neurochecks in the ICU using EHR data points. The algorithm should be able to know, when the patient is approaching imminent death based off of GCS coma scores. And we can use the criteria that Dr. Rouleau developed to increase the specificity of donor identification. And then finally, also automate the process, the connection between the OPO and the medical systems, and really understand when life support is about to be withdrawn based off of providers clicking discontinue in the EHR on life support measures. And so Sam designed a state diagram. This is basically just showing the architecture for the algorithm, specifically what the algorithm would be looking for in the EHR to successfully identify a potential organ donor. But big takeaways, 93 to 94% of potential DCD donors were not approached by the OPOs at our institution. And so, I mentioned some of the reasons for this, the fact that a lot of this process is manual, that we're relying on a process that is very prone to human error and lack of education. And so we want to automate this with a basic EHR algorithm. And this is totally novel. This has not been done yet, especially the most important parts of the automation, which is identifying when life support is being discontinued. And so right now we're having discussions with the executive leadership team at UNC to build this algorithm and implement it. We'll be running clinical trials and publishing papers because we really hope that all of you will hopefully try and implement similar programs at your own institutions. That being said, this is ECTSS. We're we're a smaller conference. We're a select group. We should be seeing each other as a tribe, and we should be, helping each other, collaborating. And our team, when it comes to ECTSS, we don't have secrets. So, if you have interest in collaborating and helping move this field forward, please contact us or approach me or my partners, and we hope that we can all work together to make improvements in this space.
Thank you. We'll open up for questions.
Well, that's fascinating that you're a medical student?
Mm-hmm. Yes.
You guys did a great job here. I think it's cutting edge, good application of technology, and potentially increasing the donor pool that could help lots of patients. So, congratulations.
Thank you so much.
Another question. Have you guys started implementing this at your institution, or have you trialed this in clinical practice yet?
So what we've got so far is the basic architecture. To actually deploy it, we'll have to collaborate with EHS providers like Epic, and that's what we're working with the UNC executives to set up.
And how difficult is that process?
Okay, be honest. Tell them.
It's actually ridiculously simple. Actually, as a tech guy,
He's a computer engineer.
Yeah.
So he knows what he's talking about.
The application of this is very, very simple. So, when Sammy came and told me about this, I was shocked that it hadn't been already implemented. And when you really look into why it hasn't been implemented, I think it's that gap of understanding. You've got the doctors who are very, they know all of the clinical information, but the tech guys don't know that stuff. And the same thing goes on the other side. It's the doctors they don't know how capable the technology is yet. So, once we bridge that divide, it'll open up a lot of opportunities for simple algorithms that can be deployed that will have a big impact on the medical space.
And how do you anticipate doing this? Because let's say your donors are not going to be at the same institution. So how is that going to work? Or is it only going to be institution specific?
So we actually did the health system workflow analysis at 2 totally different hospitals. So at UNC Hospital, we also did it at the Novant Health System, which is one of the biggest in North Carolina as well. And that's a private hospital system or community based. And actually the processes are both the same for like the transplant process. The algorithm that we're trying to implement is so far upstream that we're kind of at the point where it gets into the specifics with institutional differences. So, if this gets, the reason why we're focused on doing clinical trials and getting this information published as soon as possible is because anybody can do it.
That's awesome. Great work, guys.
So does it involve natural language processing?
No, it's more simple than that. So that's the thing. Like our research, our team initially started with like the big fancy AI stuff, the complicated natural language processing, looking at how radiology devices are diagnosing diseases. And what we realized is like actually the hardest part about it is implementation. So like even though the natural language processing, the more complex models are out there, you don't really hear much about an AI saving somebody's life because the problem is just the implementation. And then a basic algorithm that just looks at EHR data and performs a basic function like alerting providers about a change in the patient's health state. A lot of that is right under your noses. Nobody just developed it yet for the reasons that Isam mentioned.
Well, I mean, you gotta have an interface with Epic and all the major electronic health record systems, which Epic is by far the largest. But also there's other applications here. We could use it for screening for trials. For example, the last presentation could pick up all the patients who had elevated troponins and track them and maybe enroll them in a trial. And I think it's, the scope is amazing, and you guys are on the right track. So.
Thank you so much. I really didn't think about that. I haven't thought about how to use this in research, so that's good to know.